A distributor is a device in the ignition system of an internal combustion engine that routes high voltage from the ignition coil to the spark plugs in the correct firing order. The first reliable battery-operated ignition was developed by Dayton Engineering Laboratories Co and introduced in the 1910 Cadillac. This ignition was developed by Charles Kettering and was considered a wonder in its day. Atwater Kent invented his Unisparker ignition system about this time and competed with the Delco system. Description: a distributor consists of a rotating arm or rotor inside the distributor cap, on top of the distributor shaft, but insulated from it in the body of the vehicle. The distributor shaft is driven by a gear on the camshaft on most overhead valve engines, and attached directly to a camshaft on most overhead cam engines. The metal part of the rotor contacts the high-voltage cable from the ignition coil via a spring-loaded carbon brush on the underside of the distributor cap. The metal part of the rotor arm passes close to the output contacts which connect via high-tension leads to the spark plug of each cylinder. As the rotor spins within the distributor, electrical current is able to jump the small gaps created between the rotor arm and the contacts due to the high voltage created by the ignition coil. The distributor shaft has a cam that operates the contact breaker. Opening the points causes a high induction voltage in the system's ignition coil. The distributor also houses the centrifugal advance unit, a set of hinged weights attached to the distributor shaft, that cause the breaker points mounting plate to slightly rotate and advance the spark timing with higher engine RPM. In addition, the distributor has a vacuum advance unit that advances the timing even further as a function of the vacuum in the inlet manifold. Usually there is also a capacitor attached to the distributor. The capacitor is connected parallel to the breaker points, to suppress sparking to prevent excessive wear of the points. Around the 1970s the primary breaker points were largely replaced with a Hall effect sensor or optical sensor. As this is a non-contacting device and the ignition coil is controlled by solid-state electronics, a great amount of maintenance in point adjustment and replacement was eliminated. This also eliminates any problem with breaker follower or cam wear, and by eliminating a side load it extends distributor shaft bearing life. The remaining secondary circuits stayed essentially the same, using an ignition coil and a rotary distributor. Most distributors used on electronically fuel-injected engines lack vacuum and centrifugal advance units. On such distributors, the timing advance is controlled electronically by the engine computer. This allows more accurate control of ignition timing, as well as the ability to alter timing based on factors other than engine speed and manifold vacuum. Additionally, eliminating vacuum and centrifugal advance results in a simpler and more reliable distributor. Distributor cap: a distributor cap is used in an automobile's engine to cover the distributor and its internal rotor. The distributor cap has one post for each cylinder, and in points ignition systems there is a central post for the current from the ignition coil coming into the distributor. There are some exceptions however, as some engines have 2 spark plugs per cylinder, so there are 2 leads coming out of the distributor per cylinder. Another implementation is the wasted spark system, where a single contact serves 2 leads, but in that case each lead connects one cylinder. In General Motors' high-energy ignition systems there is no central post and the ignition coil sits on top of the distributor. Some Toyota and Honda engines also have their coil within the distributor cap. On the inside of the cap there is a terminal that corresponds to each post, and the plug terminals are arranged around the circumference of the cap according to the firing order in order to send the secondary voltage to the proper spark plug at the right time. The rotor is attached to the top of the distributor shaft which is driven by the engine's camshaft and thus synchronized to it. Synchronization to the camshaft is required as the rotor must turn at exactly half the speed of the main crankshaft in the 4-stroke cycle. Often, the rotor and distributor are attached directly to the end of the one of camshaft, at the opposite end to the timing drive belt. This rotor is pressed against a carbon brush on the center terminal of the distributor cap which connects to the ignition coil. The rotor is constructed such that the center tab is electrically connected to its outer edge so the current coming into the center post travels through the carbon point to the outer edge of the rotor. As the camshaft rotates, The rotor spins and its outer edge passes each of the internal plug terminals to fire each spark plug in sequence. Engines that use a mechanical distributor may fail if they run into deep puddles because any water that gets onto the distributor can short out the electric current that should go through the spark plugs, rerouting it directly to the body of the vehicle. This in turn causes the engine to stop as the fuel is not ignited in the cylinders. This problem can be fixed by removing the distributor's cap and drying the cap, cam, rotor and the contacts by wiping with tissue paper or a clean rag, by blowing hot air on them, or using a moisture displacement spray, for example WD-40 or similar. Oil, dirt or other contaminants can cause similar problems, so the distributor should be kept clean inside and outside to ensure reliable operation. Some engines include a rubber O-ring or gasket between the distributor base and cap to help prevent this problem. This gasket should not be discarded when replacing the cap. Most distributor caps have the position of the number 1 cylinder's terminal molded into the plastic. By referencing a firing order diagram and knowing the direction the rotor turns, the spark plug wires can be correctly routed. Most distributor caps are designed so that they cannot be installed in the wrong position. Some older engine designs allow the cap to be installed in the wrong position by 180 degrees, however. The number 1 cylinder position on the cap should be noted before a cap is replaced. The distributor cap is a prime example of a component that eventually succumbs to heat and vibration. It is a relatively easy and inexpensive part to replace if its Bakelite housing does not break or crack first. Carbon deposit accumulation or erosion of its metal terminals may also cause distributor cap failure. As it is generally easy to remove and carry off, the distributor cap can be taken off as a means of theft prevention. Although not practical for everyday use, because it is essential for the starting and running of the engine, its removal thwarts any attempt at hot wiring the vehicle. Direct and distributorless ignition. Modern engine designs have abandoned the high-voltage distributor and coil, instead performing the distribution function in the primary circuit electronically and applying the primary pulse to individual coils for each spark plug, or one coil for each pair of companion cylinders in an engine. In traditional remote distributorless systems, the coils are mounted together in a transformer oil-filled coil pack, or separate coils for each cylinder, which are secured in a specified place in the engine compartment with wires to the spark plugs, similar to a distributor setup. General Motors, Ford, Chrysler, Hyundai, Subaru, Volkswagen and Toyota are among the automobile manufacturers known to have used coil packs. Coil packs by Delco for use with General Motors engines allow removal of the individual coils in case one should fail, but in most other remote distributorless coil pack setups, if a coil were to fail, replacement of the whole pack would be required to fix the problem. More recent layouts utilize a coil located very near to or directly on top of each spark plug. This design avoids the need to transmit very high voltages, which is often a source of trouble, especially in damp conditions. Both direct and remote distributorless systems also allow finer levels of ignition control by the engine computer, which helps to increase power output, decrease fuel consumption and emissions, and implement features such as active fuel management. Spark plug wires, which need routine replacement due to wear, are also eliminated when the individual coils are mounted directly on top of each plug, since the power is transported a very short distance from the coil to the plug. Wasted spark. 4-stroke 2-cylinder engines can be built without a distributor, as in the Citroën 2CV of 1948 and BMW Boxer twin motorcycles. Both spark plugs of the Boxer twin are fired simultaneously, resulting in a wasted spark on the cylinder currently on its exhaust stroke. 4-stroke 4-cylinder engines can be built without a distributor, as in the Citroën ID19. Two coils are used with one coil firing two of the spark plugs simultaneously, resulting in a wasted spark on the cylinder currently on its exhaust stroke, and the other coil used for the other two cylinders. This system has been scaled up to engines with virtually an unlimited number of cylinders. 4-stroke 1-cylinder engines can be built without a distributor, as in many lawnmowers. The spark plug is fired on every stroke, resulting in a wasted spark in the cylinder when on its exhaust stroke. See also, engine control unit, ignition magneto, ignition system, SARB direct ignition, timing mark, references. External links.